Hello everyone, welcome to my talk, Tackling OpenAPI Drift, Lessons from the Acme FS Experience. First, a bit about me. My name is Ikenna Nwaiwu. I'm an independent API consultant. I'm the author of the book, Automating API Delivery, API Ops with OpenAPI. I'm also working on a report with the working title, Tackling API Sprawl, a review of internal developer portal tool support for API governance. As an independent API consultant, I help my clients solve API governance problems in three main areas. The first is API sprawl, where there's a proliferation of APIs in the enterprise and very little standardization. The second is API drift, where there's a divergence between API documentation and the API implementation. And the third is high API delivery lead times, where API design and delivery takes too long. I also provide API providers and API tool vendors with advisory services on these topics. Now, the agenda for this talk. I'll start by telling a story about Acme FS and their API drift challenges. And I'll tackle the question, is API drift a problem? I'll discuss in the Acme FS story the countermeasures they considered in tackling API drift. I'll talk about how they went about implementing a plan to solve API drift. I'll explain their results. And I'll talk about the lessons learned by this company, Acme FS, as they tackled their API drift problem. And then I'll summarize. So let's start with the question, is API drift a problem? Now, I've said that API drift occurs when API documentation, for example, OpenAPI descriptions, diverges from an API's runtime behavior. So the question is, if that is what API drift is, how widespread is this issue? Is it a problem, and how widespread is it? At Apidays Paris, I actually ran a survey with the audience, and I asked the question, if your organization builds APIs, does your published API documentation match your API behavior? 26% disagreed with this, saying their API documentation doesn't match their API behavior, and 3% strongly disagreed with this, and 3% were unsure. So you'd have there roughly 29% of people who were sure that their API documentation didn't match their API behavior, and you had a further 3% who were unsure if they had API drift. Now, I've also run this survey at other conferences earlier in the year, at an API conference in Belgium and at another API conference in Berlin. And interestingly, I found similar results. Roughly in both of those cases, roughly 30% of the audience were either sure their APIs did not always match their API documentation, or were unsure if their APIs match their documentation. And that 30% number was fairly consistent across those two conferences. Now, one question is, well, that's just, a survey I ran at a conference. Is there really any industry report that shows that API drift is an issue on a large scale? Well, the answer is yes. And there's a company called API Context, a technology provider that they build API conformance, performance, and reliability tooling. And they published a white paper in August 2024, where they analyzed hundreds of APIs from large API providers. In their report, in their white paper, API Context found that 75% of APIs which they tested had non-conformant endpoints. That's 75%. In API Context white paper, they also found that 25% of APIs which they tested did not conform to their OpenAPI descriptions in any endpoints. So all the endpoints for some APIs, all their endpoints did not conform to their API descriptions at all, which is quite a large number. Here's a selection of some of the APIs we tested. You can see that even popular APIs like GitHub and Twilio suffer from API drift. And in some APIs like Box.com and Pivotal Tracker, it's a severe issue. All their endpoints tested by API context suffered from API drift. So we've established that API drift is an issue in the industry, but the question must be asked, if many popular APIs suffer API drift, is it really an issue worth solving? Or is it something that we can just get by with? I guess it depends. I would like to tell you a story of one case where API drift was not okay and has severe financial consequences. This is the story of Acme FS, a SaaS financial technology provider I did some work for. This is a real story, but Acme FS is not the company's real name. Acme FS is a technology startup that provides a cloud-native financial technology platform used by banks across the globe. At the time this story occurred, Acme had about a 200-person strong dev team, and Acme FS's main goal was to land 4 new customers that year. As a cloud-native API-first company, Acme had 70-plus Java Spring Boot microservices running in Kubernetes, in AWS, and they embraced an API design-first practices using OpenAPI as their API description language. One of the biggest prospects that had come down Acme FS's sales pipeline was a bank that, for this story, we'll call the bank Big Bank One. Big Bank One had done some extensive analysis of vendors in the market and picked Acme FS as its top choice. Talks were in advanced stages, and a proof of concept solution was being built by Big Bank One that integrated with Acme FS's API. Things were looking good. Big Bank One ran its systems on-prem. As part of its security procedures, they used Acme FS's OpenAPI description file to validate the POC integration API traffic between their system and Acme FS. To their surprise, there were several instances where Acme FS's OpenAPI file was inaccurate or missing some OpenAPI objects entirely. Big Bank One queried Acme FS about this, and Acme FS fixed the issues they found. But as the POC progressed, Big Bank One kept finding more API drift issues. Some of the issues that Big Bank One discovered were things like missing response schema fields and objects, incorrect HTTP response codes, inaccurate response schemas, and incorrect request schemas. These API drift issues severely eroded the trust that Big Bank One had in Acme FS as a mature solution that could address its needs. In the end, Big Bank One called off the deal and went with a different provider. In Big Bank One's feedback to Acme FS on the failed POC, it mentioned 3 issues it had with Acme FS's platform, and the API drift issue was top of the list. Losing this prospect was a big blow to Acme FS and was of big concern to the CEO. On further analysis, Acme FS found that 30% of the API endpoints that customers would use in a typical workflow had API drift issues. Acme FS also had another prospect, we'll call Big Bank 2, in the pipeline, who was due to begin a POC in 2 weeks. So the big question at Acme FS was, what can we do to fix API drift issues in 2 weeks? One complication to this issue was that Acme FS's current functional testing framework was being rewritten from difficult to maintain end-to-end tests to more decoupled component tests with mocks and a better scoped API contract tests. The project would take a few months to complete, and would not be ready in sufficient time before the next POC. So what could ACME-FS do to fix API drift in 2 weeks? In order not to disrupt all the feature teams and their backlogs, ACME-FS assembled a small team of 2 engineers to tackle this problem. Here are 9 countermeasures to this problem that this team considered. First, they considered generating the OpenAPI descriptions from their Java and Spring Boot code. To achieve high fidelity in the generated API descriptions, this would involve adding annotations to many of the 70+ microservices. They could do this with the Spring-Doc OpenAPI, the Spring-Doc OpenAPI library. Now, this would be a lot of work, and because the microservices did not map one-to-one to the external-facing APIs, this is due to orchestration and transformation of payloads in the API gateway, generated API descriptions could not be used as is. It will still require some non-trivial transformation to match the external-facing API. So this option was rejected. Next, they considered adopting a stricter API design-first approach and ensuring they always generated Spring Boot server stub code from OpenAPI descriptions. They could use tools like OpenAPI Generator or JHipStar to do this. While this was a possible long-term countermeasure for fixing the root cause of API drift, it would not be feasible for fixing the OpenAPI descriptions of within 2 weeks. Also, it did not address the API gateway transformation challenge. The goal was to fix the OpenAPI descriptions, not to change the working backend code. So this option was rejected as a short-term countermeasure. Next, they considered language-oriented API development tools like Smithy and TypeSpec. These tools use programming language-based interface definition languages. They use a programming language-based interface definition language that supports the generation of server stub code, client SDKs, and OpenAPI descriptions. Now, moving the entire API development process to use a language-oriented API dev tool was not a feasible option in 2 weeks. So this countermeasure was also rejected. The fourth option they considered was consumer-driven contract testing, using tools like Pact or Spring Cloud Contract. Consumer-driven contract testing, or CDC, uses record replay style contract tests and follows a specification by example pattern to prove 2 applications can integrate correctly. Now, ACME-FS already used CDC using Pact and Pact.json file contracts to validate the interactions between internal microservices. However, the contract that needed to be fixed as part of this problem was the external-facing OpenAPI files. So CDC with Pact would not address this problem. So this option was also rejected. Next, they considered bidirectional contract testing. In bidirectional contract testing, or BDC for short, consumers generate a contract, for example, a Pact.json file contract, just like in CDC, but providers also generate a contract, for example, using an OpenAPI file. Pactflow, a Pact broker, serves as the centralized repository where providers and consumers can publish their contracts and have them statically compared. ACME-FS's problem was that it didn't have the correct provider OpenAPI contracts, and there was no consumer-generated contracts for the external-facing API anyway. So this countermeasure was rejected. The next option they considered was creating provider-driven contract tests using code-based schema assertions. In this approach, we can compare runtime payloads with the OpenAPI contract using code assertions and matches. Java tools like Rest Assured, combined with Atlassian Swagger Request Validator Library, enable the writing of automated tests that fit this pattern. Karate Labs, for example, also supports this scenario in a nice DSL. In the new version of ACME-FS's testing framework, ACME-FS was adding provider-driven contract tests, or PDC, with code-based schema tests at the microservice component level and at the top API level. But again, this was a long-term solution that would not be completed in time. So the team had to reject this option as a short-term solution. The seventh option the team considered was to write PDC tests, so provider-driven contract tests. To rephrase that, the next option considered was to write PDC testing, where tests were generated either using fuzzing or from the examples in the OpenAPI contract. Tools like Schemathesis, Specmatic, and Microx support the generation of API tests based on example values in the OpenAPI description. However, ACME-FS had OpenAPI files that didn't have many example values, or in some cases had incorrect example values. Updating all the endpoints with correct examples would take a very long time. But this was a possible long-term countermeasure to consider. However, as a short-term countermeasure to be implemented in 2 weeks, this option was also rejected. Another option considered was to use the OpenAPI validation features in ACME-FS's gateways to validate the OpenAPI files against the runtime traffic flowing through the gateway. At the time, ACME-FS had multiple API gateways like Apigee, Ambassador Edge, and the open source traffic proxy. It was also in the middle of a complex API gateway migration project. While Apigee had an OS validation policy that ACME-FS could use, the team didn't know about any other mature OpenAPI validation plugins in some of the other gateways that they were using. This and the complex migration environment made ACME-FS reject this option. Finally, the team considered using provider-driven contract testing with a validation proxy, like Stoplight Prism or Wiretap. That is, the conformance checks are done in the proxy as opposed to code-based assertions, like in the previous scenarios we looked at. The team thought this option may be a lightweight and easy to implement option because ACME-FS had created a bundle of Postman collections, which had been created by the product team and DevRel roles, that prospects could use to try the core customer journey in a sandbox environment during a POC. So the question was, could ACME-FS reuse these Postman collections and a validating proxy to run quick PDC tests on the core user journey? ACME did some quick trials of this approach, and it appeared workable. So this was something ACME-FS wanted to consider and do. So ACME came up with an implementation plan to use provider-driven contract testing with a validating proxy. First, the team created a script that started an instance of the Prism proxy that relayed requests to the ACME-FS platform. Prism was provided with the ACME-FS OpenAPI file for use in validating requests. The script used Postman's open source Newman collection runner to run the user workflow Postman collections. And the script used Postman run reporter, the Newman reporter HTML extra, to display the run reports. There was one complication though. A typical user journey involves several of ACME-FS's APIs. To make the test smooth, all the OpenAPI files had to be combined into one. Also, undocumented OpenAPI objects are not detected by the proxy if the additional properties or unevaluated properties fields is not set to true. Acme FS's OpenAPI files did not have this property set. To address this concern, the team had to transform the OpenAPI files before providing them to Prism. They updated their CI/CD API description pipeline to do the following. First, they combined the relevant OpenAPI files using the Reductly CLI. Next, they filtered out unused components and legacy endpoints using OpenAPI filter and Reductly CLI. And then they used Nick Heap's add props flip-flop tool to set additional properties to false or on all OpenAPI response objects. With the pipeline producing the needed OpenAPI file, they were able to run the tests and fix the API drift issues. So here's the result. What happened? Using the test scripts, they fixed all the API drift issues in the core customer journey in 5 days and increased API conformance from 70% to 100%. The updated API description was ready in time for the Big Bang 2 POC, which was carried out successfully without any complaints about API drift. Acme FS won the Big Bang 2 deal, and everyone was very happy. So here are a few lessons learned from the Acme FS story. The first is that the product and client solution roles wrote the user journey request collections to help reduce the time to first hello world, or TTFHW, for new prospects and to help them try out the core user journey in a sandbox environment. The tests were mostly written by one senior product director and the client solution architects who had a kind of a DevRel role. These colleagues didn't need an IDE or heavyweight programming languages or complex test frameworks to define these collections. They could simply do this in Postman. However, these collections could be reused to drive provider-driven contract tests. This was a nice coincidence. This is important from a resourcing perspective because the devs and QAs were very busy on other tasks and couldn't be diverted to write new contract tests. At the time, Acme FS used Postman collections, and you can also do this with Insomnia collections. But today, I see a lot of interest in teams also using Bruno collections. Note that Acme FS used common workflow collections, plus provider-driven contract testing, plus a validating proxy, all run in daily Jenkins workflow runs as a lightweight way to fix the API drift issues quickly. However, this was not meant to be the permanent solution as the team was building in proper provider-driven contract tests in their test framework that would run as part of their CI/CD solution. However, this short-term solution was useful in fixing the problem and getting them to close the deal. Point 2 is that when fixing, consider starting from the most common user workflows. These are the ones where drift causes the most problems. And the third point is that the trick to get this to work for Acme FS was in combining multiple OpenAPI files and automatically injecting additional properties equals false into each schema object. The OpenAPI description pipeline made this possible and was crucial for this purpose. So in summary, here are the key points. The first is that many APIs suffer API drift. For some APIs, this drift is a deal breaker and should be remediated urgently. And you can use request collections and transformed OpenAPI descriptions coupled with provider-driven contract tests as a lightweight way to fix API drift issues. Thanks for listening. Thanks for listening, and you can reach out to me on LinkedIn if you'd like to connect and continue this discussion further. Thank you.